Could you introduce yourself briefly to the audience?
Yeah, my name is Alvaro. I'm a programmer. As I wrote on the description of the conference, I'm a writer of words because I'm really interested in like literature, linguistics, all that side, and I try to combine this with programming. That's what I like the most.
Could you describe your talk a little bit as well?
So the talk was called Metaphors We Compute By. It's taken from the idea is taken from the book by Lakoff, George Lakoff, called Metaphors We Live By. And the main idea on that book is how metaphors influence the way we think, how we live, how we behave. And I thought, okay, is there any relation between those ideas by Lakoff, which is a cognitive scientist, is not some random guy writing metaphor ideas, let's say. There's a lot of research behind it and so on. I say, okay, but is there any relationship between this and programming, like the way we choose data structures, the way we name algorithms, our understanding of problems increased by the metaphor we use, like graph, cues, gossip, and so on, or they are obscuring understanding? So yeah. I try to go asking this question.
Is there any particular metaphor that you think obscures some good idea over much?
Right off the top of my head.
Yeah, it's kind of hard off the top of your head.
I think currently, or a good example from the talk, I think is the one from gossip. Mm-hmm. Versus epidemics.
Yeah.
They were trying to find how to do replication, and they understood it as gossiping, how you spread rumors. A person tells two persons, these two people tell other two people, and it gets spread, right? That's really good for understanding, like to explain it to an audience, but maybe not so good to reason about it.
Yeah.
When they found the relationship between that and epidemics, there was actually a lot of mathematics to try to stop the spreading of an epidemic. And they say, okay, we can kind of reverse this math to actually spread information.
Yeah.
So there you have a metaphor that in the context of explanation or teaching is really good, like gossip, but maybe not that good in the context of reasoning about the problem, like epidemic was. So, but maybe not so easy to explain. And another one from category theory, I was mentioning a discussion that I saw on Twitter, one sees, and Thomas also mentioned it on his talk. There was an argument between if we should say functor or we should say mappable, or however you pronounce that. And the category theories were saying, no, it's functor, it's a well-defined entity, you should use functor this, functor that. But for a person to understand, maybe it's not the best thing.
Sure.
When you want to reason mathematically about code, then functor is probably the best thing there is because there is already a theory behind it.
Yeah.
But maybe not for teaching newcomers into the theory. When you get people to use the thing, then, okay, look, what was tricking you is actually a functor. But then you expand more if the person is interested. But sometimes this mathematical language kind of gets too far from us.
Right.
Because also, as Thomas was saying on the other book by Lakoff, Where Mathematics Come From, we don't realize that we understand mathematics thanks to a ladder or a stack of metaphors that we build over the years of going to school and whatnot. So when you are doing a PhD, let's say, I don't know how many metaphors you built, subconsciously even, until you got that thing that now is so easy to see. Mm-hmm. To see.
Yeah.
But for a non-academic person, let's say, or somebody that's not too much into that, maybe that's not the best way to get there. So.
Right. Yeah, I think, we've talked a fair bit about, well, how do you teach concepts to people? And I think one thing that keeps reoccurring in our conversations is trying to pare down your language as much as possible to meet people where they are. I wonder, so functor was an example. I wonder if there are any other things that come to mind to you that are sort of overly elaborate or too far out in terms of implied understanding?
I think I don't know if I have an example to that, but related to it, I was reading also about rhetoric. One cool definition I saw is that, okay, you have grammar, they say, you have logic, and then you have rhetoric, of the old trinity. And rhetoric was how to put all this grammar and logic together, which in programming we kind of forget. We have grammar, we have logic, but we never care about getting the message across.
Sure.
But they say rhetoric is about how to explain things for the right context. So it's not the same for me bringing these theories in a programming conference than going in a non-programming context. So I think that's why it's very important to choose the right language. And again, metaphor, we think of higher, better, lower, non-better. So we say we need to lower our language because we think on these spatial ways, for example. And there are a lot of implications on this way we talk. A metaphor that now comes to mind of how this obscure understanding is with concurrent programming. We were used to the old days of code being linear and the code. A line of code meant what the next instruction, like the number were increasing, the instructions were increasing, it was the order the computer will process the code.
Right.
And I saw, I'm not sure it was Shipilev from the JVM core team, the JDK core team, that he said that that's one of the greatest illusions we have today. Like we see code in order in an editor, and we think that's the order in which will be run, because we had this wrong metaphor from back in the day of single core day.
Right.
So to reason about concurrency and line numbers, today line numbers are just a coordinate to find where the error comes from.
Right.
But not how the code will be run most of the time.
Right. Did you catch the talk on undefined behavior in C?
Yes.
Yeah. So he made a very interesting point where undefined behavior is very useful for the compiler because even in sequential code, it can just go ahead and choose and reorder your code so long as the data accesses are accurate. I think that's a good point. That's one of the key magical bits.
We are very far away from the computers of the 50s, let's say, when you will code kind of to the instructions. That is kind of not what's happening today. You never think about which computer is going to run my code, what architecture is running my code.
Right.
You never think about that.
Right.
Maybe, okay, if you write for GPU or normal CPUs, let's say, but in general, like in Erlang, a virtual machine will even be running my code.
Right.
And what I write is transform many steps until it gets to the virtual machine. The Java just-in-time compiler or optimizer is the same. It's doing so many optimization depending on how much the function are called.
Right.
That what I wrote, I don't even know if it's even what is being run by the virtual machine.
Right. Yeah.
Which is not even the computer. So.
Right. All right. Well, thank you very much for speaking with me today. Yeah.
Thanks.